For the function g of x equals 4 over x squared minus 4, to find the y-intercept, we let x equal 0. So 4 over 0 squared minus 4 leaves us with 4 over negative 4, which is negative 1. That's going to be our y-intercept. To find the x-intercept, we let y equal 0, so that g of x is the y-coordinate, and that's going to be equal to 4 over x squared minus 4. But if I multiply both sides by the denominator, I end up with an equation that says 0 is equal to 4, and that's never true, so there is no x-intercept. In order to identify the domain, we want to find out when the denominator is equal to 0. The domain is going to be when that x squared minus 4 does not equal 0. Since x squared minus 4 is x plus 2 and times x minus 2, that means x cannot equal negative 2 or positive 2. The vertical asymptotes are directly related to the domain. Since x cannot equal negative 2, a vertical asymptote is going to be the vertical line x equals negative 2. And since x can't equal positive 2, a vertical asymptote is going to happen at the vertical line, x equals positive 2. In order to identify the horizontal asymptotes, we go back to the first terms of the numerator and the denominator. And we look at this fraction, 4 over x squared. And we want to think about what happens as x approaches infinity. That's because an asymptote is that line that our graph is going to approach way out at the extremes. So when we look at this fraction, as x gets bigger and bigger and bigger, x squared is even bigger than that. But it's in the denominator of a fraction, and so 4 divided by extraordinarily large number is going to get closer and closer to 0. Altogether, that means that our horizontal asymptote is going to be the horizontal line, y equals 0. Lastly, we want to evaluate g of x at a couple of different points. First, I ask you to find g of negative 3, so that would be 4 over negative 3 squared minus 4. So 4 over 9 minus 4 is 4/5. Similarly, with positive 3 squared is 9 too. So this fraction will also be 4/5. So now let's put all of our information together to make the graph of g of x. Since the y-intercept is at negative 1 on the y-axis, I'm going to plot a point at negative 1. There's no x-intercepts, so I move on to the vertical asymptotes. The vertical asymptotes happen at x equals negative 2 and positive 2. So on my x-axis, I'm going to find out where negative 2 and positive 2 are and draw vertical asymptotes at those two places. The horizontal asymptote is y equals 0, so on the y-axis I'm going to find where y is equal to 0 and draw a horizontal asymptote there. Next, I'm going to plot the last 2 points I found. Since g of negative 3 is at 4/5, I'll go over to negative 3 for my x-coordinate and 4/5 for my y-coordinate. Same thing with g of 3 being positive 4/5. That's the point 3 4/5. Now this is enough to come up with a good sketch of our graph. On the left section, my curve has to go through my point and then approach each of the asymptotes. In the middle, my curve is going to go through my point and get over to each of the asymptotes. And on the last interval, my curve is going to go through my point and then get to each of the asymptotes. And there's a very good curve of g of x.